In 8.7, we're going to learn how to factor special products. We're going to first look at the difference of two squares pattern. If you look at a squared minus b squared, we can expand that into a product of two binomials, a plus b times a minus b. If we use the FOIL method, we can check. A times a makes a squared. A times negative b makes minus ab. Positive b times positive a makes positive ab. And positive b times negative b makes negative b squared. So I can cancel out the middle, so I get a squared minus b squared, which is what we have here. So I'm going to show you a numerical example here. 4x squared minus 9. I could square the first term and square the second term to get 2x and 3. And now I can write this as a product of two binomials with different signs. And then now we're going to look at the next pattern called the perfect square trinomial. So when we have a squared plus 2ab plus b squared, and then since a squared and b squares will be considered the perfect square, we can rewrite this as the binomial a plus b to the second power. So again, if we look at an example here, we can take the square of x squared, which is x, take the square of 9, which is 3. Since this is addition here for the second term of this polynomial, written in decreasing order of these degrees, then I can take this binomial and square it. And to double check this, I can square the x, and then double the two terms, so that's 3x. And I have to use a positive sign here for the second term, and then I can square the last one, which is 3 squared, which makes 9. So it will be x squared plus 6x plus 9, which equals the original trinomial. Now for the next pattern, we need to consider a negative sign here. So it will be a squared minus 2ab plus b squared will equal to the binomial a minus b to the second power. So to do the example here, we need to consider x squared and take the square root of that, which is x, and the square root of 25, which is 5. And we need to put a negative sign in between because of this sign, and square. Now to check this, we can take x, square it, and then we need to write the negative sign or subtraction sign, and then we need to double the product of the first and second term of this binomial. So it'll be x times 5, and then we can square 5, which is positive 25. And then we get x squared minus 10x plus 25, which equals the original trinomial. So this is why these patterns work, and these would be your answer in factored form. Okay, now we're going to do some practice using the patterns. The first one, we're going to use a difference of square pattern. And I can take the square root of 25m squared, and then that will be 5m. And the square root of 36 will be 6. And now I can write these as product of two binomials with different signs. And then the next one, I'll still use difference of squares. And then before we use it, we need to first factor out the GCF between these two terms, which is 2. And now you notice that we have 4 and 9n squared, and these could be squared through evenly. So 2 plus 3n, and I can write another one using a different sign. And the next one, I can use perfect square trinomials. I notice that I have n squared here and 36, and I can take the square root of these. And then I have a negative sign, so I'll have to use a negative sign in between. It'll be 6, and then I'm squared. And you can check. N squared, subtract, double the product of n and 6. Take the square of 6, which is 36, and this would equal the original trinomial. Okay, now let's do more practice. The next example here, we're still going to use a perfect square trinomial pattern. The square root the 9x squared and take the square root of 4. So I have 3x and 2. Now this is a negative sign here, so I have to use subtract. Okay. And the next one, perfect square trinomial, take the square root of these. Now we have two variables, got to pay attention to that. Here is still a subtraction sign, let's take that down. And then the square root of t squared is t. I'll put a square here. And then now we're going to factor out the negative 3. I'm going to pay attention to the sign. It's positive here, so I need to make a negative here. Negative 3 times negative makes positive here. So here this would be 12y. And because it's a negative here, I will have to make a positive. So negative, positive, negative. And now 3 times 36 makes 108. And I see that this is a perfect square trinomial. And I see that they have a negative here. I'll have to use a negative as well, or subtraction sign. Take the square roots of these. And these will be my final answer. Okay, now we're going to practice solving polynomial equations involving using these patterns. So here I have x squared, and I have 1 over 9 here. I can take the square root of 1 over 9 for sure. So x plus 1/3. Square this and set this equal to 0. And if we double the product of x and 1/3, we get 2/3. So it's okay. And x would equal to negative 1/3. Even though this is squared here, we only write this answer once. And for the next one, I see that I also can use the perfect square trinomial. So I can square root 16a squared. So that's 4a. Square root of 1 is still 1. And I will use the subtraction sign or negative sign because there's a subtraction sign next to the second term here. And then I can square this. And then by using the zero product property, meaning 4a minus 1 equal to 0, I know a must be 1/4. The next one, I need to rewrite this as a polynomial with the degree in decreasing order. I can factor out the negative sign. And then I could use the difference of two squares pattern. And by using the zero product property, I have two answers for C. So C can be equal to negative 4/3 or just 4/3. The next one, I have negative 18m squared plus 32 equal to 0. And I can factor out the negative 2. How about that? Okay, and I can use the difference of two squares. And my two answers for m, negative 4/3 and 4/3. The next one, I can rewrite this as a polynomial that will equal to 0 with the degrees of the powers in decreasing order. And I see that I have a perfect square trinomial. I can take the square root of x squared to get x. I can take the square root of 4/9 to get 2/3. And I have a subtraction sign here, or just a negative sign. Take it down. Square the binomial. And then by the zero product property, x would equal to 2/3. Okay, and the next one, I would again have to rewrite the entire polynomial in terms of 0. And with the powers in decreasing order so that I can factor. Okay, and first of all, I see that I also here I have a perfect square trinomial, 25s squared and positive 4. So I can write 5s, square root of 25s squared is 5s, square root of 4 is 2. And the sign that I will use will be plus. And then s, by the zero product property, will be -2/5. A window washer drops a wet sponge from a height of 64 feet. After how many seconds does the sponge land on the ground? Now, this involves a motion here where an object is being dropped to the ground. So from this point, 64 feet, this will be the initial height, s. And then when the object is dropped to the ground, the height would be 0. And there wouldn't be a initial velocity because the object is being dropped from a high point. The object is not being thrown, versus what we had with the tennis player hitting the ball, which creates a parabolic path. Okay, so when we use the vertical motion model here, we need to let v equal to 0. So I'm going to substitute 0 in for h. And since v is 0, this is canceled out, and s will be 64. Now I can factor out the -16. So this will be t minus 4. -16 times -4 makes positive 64. T squared, and I can continue to factor. Now t can be -2 or 2, but there's no negative seconds, so we could cancel out the negative number, and time will be 2 seconds. And this concludes the lesson.